Hello everyone, welcome to this lecture video. In this lecture video, we are going to discuss the memory management techniques and swapping things available in the memory management and storage management in the operating system. So in the previous lecture video, we have discussed what is memory management techniques and other things available in the memory management techniques. Continue to that base memory management and segment memory management, we can have the having the process. So what is swapping here? Swapping is a method in which the process should be swapped temporarily from the main memory to the backing store. It will be later brought back into the memory for a continuous execution. So in this main memory, having the we can look at the picture. We have the main memory in the operating system, user space in the continuous in the main memory, and also in the secondary storage have the process P1 and process 2, process P2. It will be swapped and swap in while whenever they are needed. While the process can be happen here. So what is swapping? We are coming to the swapping concept. Swapping is a method in which process should be swapped temporarily from the main memory to the backing store. So it will be later brought back into the memory for continuous execution. That is a swapping method we are using here. So whenever the process need, it will be stored in the secondary storage. We need brought back into memory for continuous. We need some execution for continuous execution where it left. So for that we have to brought back into the memory, and after the execution backing store into a hard disk or some other secondary storage device that should be big enough in order to accommodate copies of all memory images for all users. Here are the major benefits we are pros of swapping here. It offers higher degree of multi-programming. So always dynamic reallocation. For example, if address binding at execution time is being used, then the process can be swapped in different locations. So else in case of compile and load time bindings, process would be moved to the same locations. So it helps us to get a better utilization of memory. So by this kind of swapping things, we have the better utilization. Memory utilization will be better by using this technique. Next we go have the fragmentation. First we have to what is fragmentation. Fragmentation is a process loaded. Yes, a process loaded and removed from memory. Generally the process will be loaded into the memory and removed from the memory. The free memory space is broken into a little pieces. So that is a fragmentation. So wherever free memory, it will be broken into little pieces. So it happens after some time that process can be allocated to the memory block considering their small size, and memory blocks remain unused. So this problem is known as fragmentation. There are two types of fragmentation methods are here: external fragmentation and internal fragmentation. External fragmentation can be reduced by rearranging memory contents to a place all free memory together in a single block. So internal fragmentation, having the internal fragmentation can be reduced by assigning the smallest partition which is still good enough to carry the entire process. So this is the two types of fragmentation here using here. So external fragmentation and internal fragmentation. External fragmentation have the piece of breaks. We can able to look at the screen. So all place all free memory together into a single block. It will be merged into a single block wherever free spaces. So internal fragmentation can be reduced by assigning the smallest partition which is still good enough to carry the entire process. Wherever the memory is empty, the single fragmentation can be used very efficiently. So what is this a fragmentation thing here? Then what is paging? Paging, we are started with the paging here. So fragmentation is an important concept in the memory management, things in the storage management. Next we move to the paging. Paging is an important concept. In this, paging is a technique that eliminates the requirements of continuous allocation of main memory. In this main memory divided into a fixed slice of blocks of physical memory called frames. The size of frame should be kept the same as it is. So in this picture we can able to see how the process P1 and main memory process P2 and secondary memory, how connected. So there are major benefits by using the paging are simple to implement, it is memory efficient, and also a lot of advantage for by using these things in the paging concept. In the fragmentation we have discussed in the this video. I hope you all understand why the storage management concept of fragmentation, paging concept, and etc. Thanks for watching. We can see the next topic of paging in the next video. Thank you.